over some basic differentiation rules. So these are the ones that we are going to be going over in this video. So to start, the derivative of a constant is always 0. If you think about a graph of a constant function, like let's say my graph y equals 5, where 5 is a constant, that's going to be a horizontal line. And the derivative is your slope, so the slope of that line is always going to be 0. So that's this first one. The derivative of x is 1. The one that you're going to use the most often is number 3. And this one we call the power rule. For this, if I have the derivative of x raised to the nth power, where n is a real number, that equals n times x raised to the n minus 1. So we think of it as bringing the exponent down and then decreasing your exponent by 1. Let's do a few examples of that. So first one, I want the derivative of x to the 12th. So again, think of it as bringing the exponent down. I still have my x, and now decrease your exponent by 1. That's going to be 12x to the 11th power. We will have to rewrite what we have sometimes so that we can use the power rule. So we have two examples of that. If I have 1 over x squared, that's the same thing as x to the negative 2. So now that I am in this form, I can use the power rule again. So I'm going to bring down my exponent, and then be careful, decrease your exponent by 1. So negative 2x to the negative 3. And then in general, we don't want to leave our answers with negative exponents, so I'm going to rewrite this as negative 2 over x cubed. Last one, I have the square root of x. If I take the square root of something, that's the same thing as raising it to the 1/2 power. So I'm going to rewrite it as x raised to the 1/2. Now take the derivative of x to the 1/2. I'm bringing down that 1/2 power, decreasing that 1/2 by 1. And just keep in mind if we need to do it on the side. 1/2 minus 1, get your common denominators. We get negative 1/2. So just a few examples of the power rule. The other properties that we have, if I am taking the derivative of a constant times a function, that is equal to the constant times the derivative of the function. So basically, if I'm multiplying by a constant and I'm taking the derivative, kind of just keep the constant there, but focus on taking the derivative of the function. Last one, if I'm taking the derivative of two functions that are added or subtracted to each other, you can just take the derivative of the two functions and add or subtract those derivatives together. Notice that this does not include multiplying or dividing. There are special rules for those. Those are called the product rule and the quotient rule. And I will have those linked in the description if you are interested in the product rule or the quotient rule. Let's do some examples using these properties. So to start, I want to take the derivative of negative 3x to the 5th. So I'm going to bring down the 5. I'm keeping the negative 3. I'm going to bring down the 5. Decrease your exponent by 1. Now I did have that constant out front of negative 3, so I'm going to multiply those together. We get negative 15x to the 4th. Number 2, y equals pi squared. If I'm taking the derivative with respect to x, pi squared is just a constant, so the derivative of pi squared is 0. Next one, y equals e to the x squared. Kind of similar to the pi situation, e is a constant. So when I take the derivative, we'll say y prime. I'm going to bring down the 2, multiply it to the e. 2 times e times x raised to the first power, but keep in mind that's just the same as 2 times e times x. And I should box these. Number 4, let's rewrite this one. This is going to be 1/3 x to the 1/3. Taking the cube root of something is the same thing as raising it to the 1/3 power. When I take the derivative, bring down the exponent, and I'm multiplying, so I get 1/9. X 1/3 minus 1 is negative 2/3. Number 5, same thing, let's rewrite it. This is 5/3 x to the negative pi. When I take the derivative, bring down the negative pi, I'm multiplying, negative 5 pi over 3 x to the negative pi minus 1. And then if we move my negative exponent into a denominator, I get negative 5 pi over 3x to the pi plus 1. I'm distributing a negative through that negative pi minus 1. I have a couple more examples. I'm going to multiply 3x plus 2 squared first. So this problem would be a great problem to use the product rule on, but this video assumes that we don't know the product rule. So we multiplied all this out, and we are going to use the power rule. So let's use our power rule. Bringing down the 3, multiplied to the 9, 27x squared, plus bring down the 2, multiplied to the 12, 24x. And then 4 times x, that's just going to be 4. And there's our derivative. We have one more example. This one's pretty algebra heavy. But first, same thing as before, I need to rewrite this. This would also be a great example to use the quotient rule on. But since this video assumes we don't know the quotient rule, we are going to manipulate it so that we can use the power rule. So first thing I'm going to do is take each term in the numerator and divide it by the square root of x. So this is going to be x cubed over x to the 1/2 minus 3x squared over x to the 1/2 plus 7x over x to the 1/2 plus 5 over x to the 1/2. And then we're going to simplify each term separately. So I get x to the 5/2 minus 3x to the 3/2 plus 7x to the 1/2 plus 5x to the negative 1/2. Notice now we can take the power rule. So my derivative, I'm going to say y prime, is 5/2 x, bring down that exponent, decrease your exponent by 1, minus, bring down the 3/2, multiply by 3, we get 9/2 x, subtract 2/2, you get to the 1/2, plus 7/2 x to the negative 1/2, minus, because I'm bringing down a negative 1/2, 5/2 x to the negative 3/2. We could rewrite the negative exponent terms, but we're not going to do that in this video. And those are a few basic differentiation rules. Thank you for watching this video.